Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a decentralized social network on the blockchain. In case you missed the last video, I'm doing a full-length tutorial series on this channel where I'm showing you how to build this application step by step. So go check out that last video in this series if you haven't already. And when the series is done, I'm going to release the entire thing on my website with an article and a full-length compilation video with an explainer and all that kind of stuff. So let's continue on with our tutorial where we're going to continue building out the smart contracts to actually create posts on the blockchain. And if you're enjoying this tutorial series, click the like button down below and click subscribe. That really helps these videos get found so that more people can become blockchain developers. Now let's continue building out the smart contract for our social network. I'm going to do this by writing the source code here, with Solidity inside this file. And then I'm also going to simultaneously write tests that check that our code actually works while we're developing it. And I'll do that in a separate file written in JavaScript, just like we used here in the console. So let me explain why I'm doing this. It's going to save us time. Writing tests while we write the source code means we don't have to go back to the console and check that our code works every single time. I showed you how to use the console here by, checking the name, but let's say we added another function and we wanted to make sure that that function worked and also the name worked. Well, we don't have to go back to the console and, call the name again and then call the function and keep doing that every time we, change our behavior. We're going to automate this process by creating a new test file that can, ensure that our code works while we're building new functionality. And I'll put that file inside of a new directory. I'll go to my terminal and I'm going to exit the console, say exit. Okay, so I'll create a new directory for our tests. I'll say mkdir, I'll say test / All right, you can see in my editor that a new test directory was created here. Now I'll create a new file for the test. I'll say touch test / capital S social, capital N network.js. All right. So now we see a new file, and this is where we'll actually write all of our tests. So I'm going to use two tabs here. And you do a 2-column layout. I'll put the source code here for the smart contract, and then I'll write the test on this side. We're going to write our tests in JavaScript, and we're going to do that with the help of two libraries that come bundled with the Truffle project. The first is the Mocha testing framework. This is going to allow us to write test examples, which we'll see here in a minute. And we're also going to use the Chai assertion library. All right, this is going to allow us to write test assertions. You can see assert equal. All right. So we'll see plenty of examples of this, but just know that we're using these two libraries while we're writing our tests. And also, I'll mention another reason why testing is so important. It's critical to ensure that our smart contract code is perfect before we deploy it to a blockchain. Remember that you can't actually update smart contract code once it's on a blockchain. All right, once you've deployed it, it's there forever and you can't change it. And that's what makes it a smart contract. It's immutable, it's unchangeable. So we want to ensure that we don't have any bugs before we put them on the blockchain, and our tests are going to help us do just that. So let's get started. First, inside this file, I'll import the smart contract just like we did in the migration file. I'll do this. I'll say const social network equals artifacts.require, and then we'll say social network.sol. Again, you can just copy this line, let's see here, from the migration file. All right, this is the same, okay? That's going to bring the smart contract into this file. Next, I want to require the Chai assertion library. I'll do that like this. I'll say require Chai, all right? And then I'm going to use require Chai as promised. This is also inside of our package.json file. And I'm going to call should, okay? So this is the same thing as just putting these all in the same line, but I'm going to break it up so that it's easier to read. All right? So now we can create the skeleton for our test by saying contract, all right, and then pass in social network, just the name, and we'll pass in a callback function like this. And then we will write all of the code for the tests inside of here, okay? This callback function has a variable which is going to contain all the accounts that were provided to us by Ganache. So this variable is going to be an array that's going to be all of these accounts right here. Okay, and we can use those accounts as examples inside the test. Okay. So let's go ahead and write a basic test to see if the smart contract was deployed to the blockchain. First, we'll say let social network to keep a copy of it. This is the variable that we'll use to represent the deployed smart contract. And we'll say describe deployment. All right, and then I'll pass in a function. And what I want to do here is create an example and just say it deploys successfully. All right, and then I'll also pass in a function here. All right, so how do we check to see that it was deployed successfully? Well, remember inside the console, we returned the address. So what we want to do is assume that if the address is there, then it deployed, okay? Remember from the console, we did that just like this. We said social network equals await social network dot deployed. All right. Now we've already declared social network here with let, so we can assign this variable value. All right. But in order to use this await keyword, it has to be called inside of an asynchronous function, hence the async await pattern. We didn't have to call the async keyword inside the truffle console. It just works natively. But inside this test suite, we have to add an async keyword here. And then we're also going to put it here. All right. This is going to allow us to use this await keyword inside this function. Otherwise, it's going to blow up on us. All right. So now let's check for this address, just like we talked about. We'll say const address equals await social network, lowercase social network address. Okay. And then now we want to make sure that the address is not blank. I'm going to do that just like this. I'll say assert not equal address 0x0. All right, we'll move a blank address. And then I'm also going to check to make sure it's not an empty string, it's not null, and it's not undefined. So I'll do that just like this. Boom. So that's how we write the assertions. Just assert not equal, pass in the first value, and then compare it with the second value. So address right here, and then 0x0. It's not empty string, it's not null, and it's not undefined. All right. So now let's just run the test and see if it works. Go to the terminal and say truffle test. All right, it works. Boom. We've got a working test suite. Let's continue creating some more tests. First, I'm going to create a new example like this. Say it has a name, just like we did here. And then I'll pass another function, async, and say const name equals await social network name. And then say assert equal, right? Not equal, but equal. Say name. And we'll say Dapp University social network. All right. So we got one problem. We don't have an instance of social network yet. So I'm going to remove this because I don't want to have to do this every time. Like I might have to say, this, which I don't want to do. I want to do it twice as I continue writing more, test examples outside of this later. So what I'm going to do now is say before async, and then pass in social network equals await social network deployed, and then remove it from here. This is going to reduce duplication, and it's going to allow us to, keep checking this variable value after we create more specs or tests after this deployment description, okay? So I'll save that, go back to the terminal, and let's run the tests. All right, it passes. Awesome. So we have our test suite set up. So now let's go ahead and continue building out the rest of the smart contract. Let's make a quick list of everything we want the smart contract to do, okay? We'll say it must create posts. All right, these are the social media posts. And then it also must list all the posts. All right. And then it also must tip posts. Okay, these are the three core functions that we want the smart contract to do. Okay, allow people to post, see all the posts people have created, and then allow other users to, tip the post with cryptocurrency and make those posts, appear more relevant. Okay, and then whenever the tips are created, the authors will receive the tips. So in order to do that, let's go ahead and just write this out as a list over here in our tests. We'll just say describe posts. So I'm going to give us some space here. And I'll pass in this asynchronous function. All right. And here I want to create, three examples that, describe all the behavior, right? We'll just say it creates the posts, it lists all the posts, and it tips the posts. All right, boom, there we go. Those are the three core examples that we're going to use whenever we're developing out the smart contract. And this describes exactly what the behavior is going to be, right? This list is just moved over here. It creates posts, it lists posts, and it allows users to tip posts. So let's focus on this first part. It allows users to create posts, okay? So the first thing we want to do is create a function that allows users to do this. So let's hit enter and say a function. All right, that's the keyword that we use inside Solidity. Say create post. All right, so here's just a basic function structure. But we need more than just this. We can write all the code for creating the post inside of here. But we need some content. We need an argument. Okay, so whenever someone creates it, they're going to have a variable called content. That's just going to be some sort of string like this. If you're posting your status on a social network, that would be the content of the post. And we'll put that inside here like this. Say string content. Okay, so this is going to be a local variable that's different from this state variable, right? This is just an argument passed into the function, and we'll have access to it inside of here just like this, all right? Content. So you'll notice this looks slightly different from the state variable. It has an underscore. That's just a naming convention used when writing Solidity code that comes from other languages as well to let you know that this is a local variable and not a state variable, okay? So it's nothing special. You don't necessarily have to have this here, but I do it just so that it's easy to read and know that this is a local variable, not a state variable. So next, we also need something called memory here. All right, this is just a modifier that Solidity requires us to use whenever passing this in. And we also want to be able to call this function outside the smart contract. So currently, if we try to call this from our test or in the console, it wouldn't work because we have to declare it public. Just like this, all right? So once we pass in the content for our post, we need to actually, create a post itself. So how do we do that? Well, I'm going to use something called a struct in Solidity. So Solidity allows us to create our own data structures like this. We can use a struct keyword, all right? And then we can call it anything we want to. So I'm just going to say posts. And then we can use some curly braces just like this. And we can define all of the attributes for the post. It's really simple. You just say uint ID. All right, this is going to be the unique identifier for the post, just like an ID inside of a database. And this is going to be, say, string content. All right, that's where we're going to store this value here. All right, then next, we'll say uint tip amount. All right, this is going to be the amount of tips that someone can give, and we can update this. And then next, we want to say, we want to keep track of who the post author is. In this case, this is going to be an Ethereum address, just like the username. So we'll say address, author. Okay. So I'll make a mention of this. The uint just stands for an unsigned integer. That means this has to be an integer value that can't be negative. That's what unsigned means, right? So, an integer could be like 1. A signed integer might be -1 because it has a sign in front of it, but we don't want it to do that, right? And then, string is pretty self-explanatory. And like I said, address is just like the addresses we saw in Ganache. These are like the users on the network, okay? So that's how we model the post. We create a struct that has an ID, has content, tip amount, and author. That's all the data we need to store a post. Now that we have this, we can actually create a new post inside of the function, just like this. I'm going to move these tests over momentarily and give ourselves some more space here to work with. So we could create a new post just like this. Just say post, all right? And then this is going to allow us to pass in all these arguments, the ID, the content, the tip amount, and the author, all right? So we can just say, for right now, I'll just hard code and say ID equals 1. We're going to change this momentarily, but I just want to show you how this works. So we can say ID, say content, which is going to be the content passed in here. And then the tip amount, whenever we start, is going to be 0. So I guess I got to do that as well. Say 1. All right, so ID 1, content, tip amount is 0, and then the author. So who is the author? Well, Solidity gives us access to a global variable called message, or MSG, and this has this allows us to read some other arguments, one of which is sender. All right, that's how we find out the person who is calling this function. So this is a special argument essentially inside this function that we don't pass in here, right? You don't see it, but we can actually declare who the sender is, who's calling this function. I'll show you that in the test here in a second, and that's going to tell us who the actual post author is, whoever called this function. All right, so that's how you create a new post struct. So we need a place to put this, actually stored on the blockchain. This just instantiates it. Whenever we create this, it just gives us a new post, but it doesn't actually save it. So how do we do that? Well, we're going to use something called a mapping. All right. So Solidity allows us to create something called a mapping like this, say mapping. And a mapping is essentially just a key value store that allows us to store data. Okay. And because I'm declaring this mapping here, it's going to be a key value store that actually writes information to the blockchain itself. This is going to kind of help us treat this smart contract like a database with the blockchain. So it works a lot like an associative array or a hash in other programming languages. So you can say uint and then say post. All right. So this is the key. This is the value. The uint is going to be the ID of the post, just like this right here. And then the value is actually going to be a post struct. All right? So that's how we'll store this on the blockchain. And we can add the post to the mapping by first creating a posts variable. All right, just like this. So mapping posts is going to be a structure that stores posts like this, uint posts, right? We can also declare this public so that we can fetch posts from the mapping later, just like we did with name. All right, this is going to be give us a reader function, or we can pull this information out of here, like name, posts. So we could have a post function, pass in an ID, return the post. So now let's actually add this post to the mapping after we've created it. We'll do that just like this. We could say post equals post like this, and then say posts, and then we want to give it the ID where this post is going to get stored. In this case, if the first time we call this function, it'd be 1. All right, just say 1. This is the same ID, and then we'd say let's be explicit about this. ID equals 1. Say ID. All right, just so you see where it's coming from. And we just pass in the post like this. All right, so sorry, I want to change that. So post equals the newly created post and then we put the post inside the mapping just like this. The key is the ID, right? The same ID here. And then the value is going to be this post itself that we just created. All right. So that's all the basics that you need in order to actually create the post. So I'm going to change this a little bit because we don't want to just hard code this ID. We actually want to, create a new ID anytime a post is, created. I'm going to do this with a counter cache, which will look like this. We'll just create a new variable at the top. So under name, I'll say uint. It's going to be an unsigned integer, public, post count. All right, and this is going to initially equal 0. So what this will do is keep track of the number of posts that get added to this mapping. All right, and I'll do that like this. I'll say post count, and I'll increase the value by 1 whenever we call this function. All right, so the first time we call it, post count is initially going to be 0. All right, and after we increment it, it's going to be 1, and then we can use that value as the ID like this. All right, and then also here. So the post count essentially will be the ID once we've updated it right here. And then every time we call this function, it'll increase, right? The next time it'll be 2, the next time it'll be 3, and so on and so forth. All right. So I'll say increment post count. And that's what this plus plus means. It means just add 1 to whatever the previous value was. The first time it'll be 0, then it'll be 1, then 2, etc., etc. All right. The next, we'll say create the post. And now what I want to do is, make this a lot simpler. Instead of doing this on 2 lines, I'm going to do it on 1 line. All right, so we've got post count here. And instead of assigning this value to post first, I'm going to do it in one shot, just like this. Say, boom, done. All right, so this will just create the post struct and add it to the mapping all in 1 line. So here's the post mapping, here's the ID, which is the key, and then the value, which is the post, just like this. Boom, done. That creates the post and saves it on the blockchain all in 1 line. All right, awesome. So let's go ahead and write some basic tests for this. We're going to add a few more lines to this function, but I want to focus on the test suite for 1 minute just to make sure that we can get this rolling. So first I'm going to call this function inside the create post example. All right, I'm going to say social network. All right, we have a copy of this already because we created it here inside this before hook, right? So say social network create post. All right, just like we did here with name. And then I'm going to pass in the value for the content. All right, so I'll say this is my first post. Okay, so that's basically how you would call a function inside Solidity. But we need to specify who the author is. Okay, so remember I talked about this msg.keyword here, msg.sender. We need to know who's actually sending this function. So we do that with function metadata. And from the client perspective, right, inside JavaScript, we pass in function metadata after the regular arguments, right? This function just takes 1 regular argument, but it takes an optional object after that. And this is where we'll add all of the function metadata, okay? So we'll say from, and this value right here, from, is going to correspond to msg.sender. All right, so from equals msg.sender on the Solidity side. All right, so here, how do we pass in the address for this? Well, if you remember a minute ago, I talked about the accounts getting included inside of here, right? You can see all of the accounts in Ganache right here, all right? So I can also break this out. We could read account like this. We could say accounts 0. We could fetch it out of the array. But instead of doing that, I'm going to actually specify the account that's going to be called here with a specific variable. So I'll use an array here instead, and I'll list out 3 different accounts that we're always going to refer to inside of this test example. All right, we'll say deployer. This is going to be the account that actually deploys the smart contract to the blockchain. I'll say author. All right, this is going to be a person who creates posts. And then I'll say tipper. This is going to be a person that, creates tips on posts. So, social network, create post. This is my first post from author. Boom. So that's going to be the address of the person who's creating the post. And that's exactly who's going to correspond to msg.sender right here, which is going to get saved as the author value inside of this post mapping. All right. So let's call that inside of our tests by saying await. All right. And then we'll say result equals that. And in order to access this value on down the line, I'll say let result. Okay. And then next, I want to ensure that the post was created. So I'll say post count equals await post count. All right, we can say post count here. And so essentially, we want to dig into this result and see, that it was created and that the post count increased. So those are the two conditions we're going to check whenever it creates the post. So how do we do that? So first, let's just do a basic check that the post count was increased. So we'll just say success. And we'll say assert equal post count equals 1. Because remember, it was initially 0. But now we want to make sure it's 1. Okay. And I'm going to go ahead and just do one pane here. So save that on the test. Say truffle. Test. Oops, looks like we had a little problem here. I forgot to finish writing this line. So post count equals await social network dot post count. All right, sorry about that. So let's save that, go back to the terminal, run truffle test again. All right, it passes. So this is a little misleading. These aren't really passing, so I'm going to comment them out for now. Just comment out like this. All right, that way we won't have this misleading information whenever we run the new tests. Okay, so the post count was increased. So now we want to actually dig into the post and actually ensure that the values are set correctly. So we need to write some more code in order to do this. So Solidity allows us to create something called events, all right, that get triggered whenever we call them. So I'm going to trigger a new event here. And we're creating this event to track the values that were stored inside of the post, okay? These events can be triggered from Solidity smart contracts and subscribed to by external consumers. The external consumers can listen for them and get the information from the event and do stuff with that information. And that's exactly what we're going to do inside of our test. We're going to subscribe to the event and read its values and check that the data is correct. And that's exactly what was in the post. So let's create a new event inside of Solidity like this. It's pretty easy. We just use the event keyword, say event, post, created. All right, we use open, close parentheses with a semicolon. And then I'm going to use new lines here. So I'll say uint ID. It's going to be the same values, but we'll use commas instead of semicolons. We'll say string content. Say uint tip amount, and we'll say address author. All right. So we can trigger the event pretty easily inside Solidity. We'll just say emit post created. All right, say post count, say content 0 msg.sender. It's basically the exact same values we passed into the function. So let's just run the test again and make sure everything works. We didn't break anything. All right, it works. So now we can go back to the test and log out this result. And this result is going to contain the information for the event itself that will allow us to verify the data from the post. So I'll just do this. I'll say console.log. Let's see here. Result. All right. So I'll save that and see what it looks like whenever we run the tests. And this will show you the structure of the result. We can kind of inspect it and then see the information we want to pull out of the result in order to verify it. All right. So here's the result. This is an object that has a transaction. It has a receipt, and we want to dig into this receipt to get this value here, the logs. All right. And the logs is going to contain this event post created that we just added inside Solidity. And this event's going to contain all the data from the post itself. Okay. And that's exactly what we want to do in order to verify the data. So, like I said, it's an event. So result is, it's a object. So say, result logs. All right, you can see logs here. Logs. All right. And then logs has, is an array. We can get the first item out of the logs. All right. So it's a 0-base index array. And then args. And this is going to be the event. Say const event. Boom. Now the event is going to have, let's just go ahead and log the event and show you what's inside of it. So I'll do that again. Run the tests. All right, so here's the values that are inside the event. It's got the ID, the content, the tip amount, and the author. All right, so we can inspect all those values just like this. We can inspect that the ID is correct, that the content's correct, the tip amount, and the author. We'll do that just like this. Boom, done. Assert equal event.id to number, all right, because it's a big number in JavaScript. Post count to number. ID is correct. All right. So post count's here, and here's the event ID. Event content, we want it to be, this is my first post. Event tip amount should be 0. Event author should be the same author that created it. All right. So save that, run the test. All right, it passes. So the next thing we want to do is add a final bit of behavior to this function. We want to ensure that the post actually has, some content inside of it. We don't want somebody just creating blank posts on the blockchain. All right. So we can do that like this. We can create a failure case. This is a success case. And we can say failure right here. Post must have content. So we'll say await social network dot create post. Let's just copy this. And we'll take this off. And we'll do empty content from author. And we should say should be rejected. This should fail. Okay. So currently it won't fail, but we want to create the test where it will. So we'll go to the source code and use something in Solidity called a requirement. Okay. So we'll say require valid content. All right. So there's a special function in Solidity called require. And whenever this function is called, it checks for true or false. Okay. So if it's true, then this is okay. Okay. This function won't do anything else, and the rest of this will continue execution. But if this evaluates to false, this will stop execution, and none of this code is going to get called. Okay. And also any gas that gets used in calling this function will be refunded back to the caller. I'm going to make a mention of gas here in a minute. I know you haven't talked about it much, but I'll revisit that topic here in a second. Okay. So essentially what we want to do is require the content is valid. We want to create an expression that's going to evaluate to true if it is valid and false if it's not valid. So that's pretty easy. We can just say bytes content. All right, this just takes the content, which is a string, and converts it to a bytes array. And say length, we say is greater than 0. Boom. Essentially, we're just checking that this string actually has some content inside of it. If it does, as a bytes array, it's greater than 0, then it'll be true. This function will continue execution. And if it's not, it'll be false, and it will stop, and none of these, will be executed. So let's run the test, see if it works. All right, it passes. All right, so that's it for this section. We've done a lot of work so far. You've created a new function inside the smart contract to create posts. You've learned about mappings and structs inside Solidity and all kinds of good stuff, right? We've written tests. You've covered a lot of ground, so you should be really proud of yourself, all right? We're going to revisit some of this code in the next section, talk about gas, refactor some of this, and we're going to move on to listing out the posts and also creating tips, all right? So let's go on to that next section.